Let's look at this build your understanding problem. We said that each question was a trial, so that means we have 8 trials because there's 8 questions. We said the probability of success on any one trial was 0.2. And we're interested in the probability that the student gets exactly 2 of the questions correct, in other words, exactly 2 successes. We'll use our formula that the probability of any x value is n combinations of x times p to the x power times 1 minus p to the n minus x power. By the way, you do want to write down the formula you're using. That will be part of what I award partial credit for in the exam, is just you writing the formula down. Now this particular problem is asking us for p of 2, so let's put the numbers in. N is 8, so I have 8 combinations of 2. P is 0.2, and we'll be raising that to the 2 power. Then we have 1 minus p, so 1 minus 0.2, and we're raising that to the 8 minus 2 power. And again, you want to write down this step exactly in this form, because part of the partial credit I will be giving you is for seeing that you put the right numbers in the right places. Now, to enter this in the calculator, we want to do a little bit of simplifying. Specifically, 1 minus 0.2 is 0.8, and 8 minus 2 is 6. And again, you want to write this step on your paper, because if you hit a wrong button and get a wrong answer, it won't cost you much if I can see that this is what you are putting in your calculator. If I can't see what you are putting in your calculator and then it comes out wrong, that's going to cost you a fair bit. So write this down for me. And then entering that in your calculator, you should have gotten 0.2936. Let's round to 3 decimal places. So we'll write 0.294. In other words, 29.4%. One last thing to cover in terms of the binomial probability distributions is the mean and standard deviation for a binomial random variable. We already have formulas for these for discrete probability distributions in general. However, there's a simpler one that we can use if we know that we have a binomial. The mean is simply n times p, where n and p mean what they usually do. And the standard deviation, it's got a square root, like standard deviations always do. And under the square root, we're going to have n p times 1 minus p. So, for example, a die is rolled 480 times. Find the mean and standard deviation of the number of 2s that will be rolled. So we've got a binomial random variable, x, and that's counting the number of 2s. So 2s are our successes. And the way I know that is that 2s are what we're counting. Let's see, the die is rolled 480 times. That's our number of trials. So n is 480. And then for these formulas, we also need to know what p is. Well, what's the probability of getting a 2 if you roll a die? It's 1 out of 6, so 1/6. We're also going to need to put 1 minus p into the formula, so let's just go ahead and compute that right now. 1 minus 1/6. Well, 1 is 6/6. So 6/6 minus 1/6 is 5/6. Okay, here we go. Our mean is n times p. It's that simple. So we're going to have 480 times 1/6, which you can do in your calculator by just doing 480 divided by 6. And that gives us 80. So if we were to do this experiment of rolling a die 480 times, if we were to do this experiment over and over, we would expect on average to get 80 twos out of the 480 rolls. What would the standard deviation of the number of twos be? We're going to compute n times p times 1 minus p under the square root. So under the square root, we have 480 times 1/6 times 5/6. Now, we already computed 480 times 1/6. That was our mean, and we got 80 for that. So what we need to compute under the square root is 80 times 5/6. Don't forget to write the square root, because otherwise you will forget to do it. At least that's what happens to students all the time. Also, don't forget that I need to see what you're putting in your calculator. And rounding off to 3 decimal places, we get 8.165.